stå på podiet så mycket?
Nej, det är för de som ska presentera. Jag ska bara prata. Take your seats, please. So, do this in might be some. Very welcome to and this year's presentation of 6 most fantastic student projects. This full time, and they will do some presentations. And after that, some possibilities for asking more details. So at the presentation, if you have some more general questions, please, acceptable, but don't go into details. Then you can go to in every project. And with that said, no further ado, I would let the first project start their presentation.
Thank you. So, for the most interesting project, I think, we have AutoBike, an autonomous bicycle platform. My name is Danny Bengtsson, and I'm the project manager of this project. The AutoBike project is an autonomous bicycle platform, which is with the purpose of validation testings of safety systems for Volvo's autonomous cars. And this is the third iteration of this project here at MDH. The previous project, where we have the bicycle over there, is a functional self-balancing bicycle. It uses a PID controller to actuate on the steer angle to counteract the lean angle to keep it from falling down. The only actuators controlled on the bicycle is the steer angle and the forward speed. The lean angle is measured with an IMU sensor, and the platform, the computational platform, is the Roborio, which runs on LabVIEW. The steer motor is a DC motor, which uses position control to balance the bicycle. And the drive motor is the original Crescent electric motor, driven with velocity control from an external motor controller. So the goals for this year's project is to create another self-balancing bicycle on a completely new platform. Still, the steer angle and forward speed is the only actuators manipulated, and we also have to balance the bicycle with the test dummy mounted on it. And lastly, we are to develop a positioning and path planning algorithm to make the bicycle go autonomously from one point to another. All this while still not messing with the radar cross-section of the bicycle, meaning that it should still resemble an ordinary bicycle with how it looks. So when we started this project, this is what we had. We had the old AutoBike to use as reference to build upon when we built it on this new Monarch Sture bicycle. This one has a centered place motor, which is used only for assistance driving while bicycling. And we still use the Roborio platform, and we also received a expensive heavy-duty IMU sensor, the VN200, which has an internal Kalman filter for fusing IMU data with GPS data to get a better accuracy INS data. And this is the list of all the tasks we had set out for this project, and it is divided up among the different competence pools that we worked in during this course. Starting with the electronics, we began with cutting out the original motor controller of the drive motor. This because we couldn't, it was only designed for assistance driving and we couldn't communicate with the motor through it. So we connected the motor itself with its phases up onto an external motor controller. We also developed a power distribution board of our own with battery protection for low voltage and high current. And we have some isolations to protect digital outputs and inputs and our expensive Roborio and IMU sensor. So for the motor controller, we use an ODrive, which is an open source platform, and we use this controller to control both the steer motor and the drive motor. It has two motor channel outputs, which can peak at 100 amps, and it uses a cascade control for position, velocity, and current control. And because it was an open source, we could create our own communication protocol to better communicate with the ODrive through LabVIEW. And the goals for the mechanics design on the bicycle was, of course, make it resembles an ordinary bicycle, and this was done through hiding all of the electronics inside of an ordinary bicycle basket, and then wiring every cables inside of the frame of the bicycle. And we also did some modifications of the basket, making it mounting it onto the frame instead of mounting it on the handlebar to not interfere with the steering motor. We also developed our own radio controller for steering the bicycle when it's not driving autonomously. This was, we developed this because we wanted to see some feedback like steer angle and velocity when we are driving and not being, we're not having it hooked up to a computer. This radio controller is based on a micro zero Arduino card with wireless SPE communication. When simulating the balance controller, we used Simulink as a simulation program, and we used the point mass model. The point mass model needs, among other parameters, the center of gravity position, and we measured this through by hanging the bicycle in the ceiling in 3 different positions, and for each position we measured the crossing of all the 3 hanging lines to get an approximation of where the center of gravity is. And for the absolute positioning, we use data fusion between either odometry data, which is the amount of steering and amount of forward velocity we have, fused with either GPS or UVB depending on the situation. For example, UVB, we have the anchors standing behind the bicycle there. We position them out just like you do with satellites from a GPS and this helps with working with the positioning both inside and outside, but on a smaller scale. The data fusion was done through an implemented Kalman filter in LabVIEW. And this, together with the kinematics model of a bicycle, we could make the bicycle drive. We should make the bicycle drive from one point to another. We have designed 2 different path planning, which is one offline and one online. We have only developed one online path planner, which I will go through. So this one is not optimized for a whole path, it's just optimized for going from one point to another online. And if we see the red arrow as the bicycle passing through a waypoint with the arrow pointing in the direction, we start with measuring the delta theta, which is the angle to the goal, and start increment the steering towards the goal. When we reach half of the angle goal, we start to balance, steer up the other way. This will create an S shape of the path, and hopefully when we are straightened up, we will point towards the goal. So for the results of this project, we have created yet another balancing bicycle that looks like an ordinary bicycle. It has a test dummy mounted on it, and we have absolute positioning with ultra-wideband, and we have it with GPS of choice, but we have not yet tested a GPS due to the weather conditions last month. And we have developed a path planner for this, although it needs further work and is not completely finished. So for future work is of course to test out this path planner and positionings, clean up the components basket, which looks a little bit of a mess, and make it weatherproof for outside use. And also we need to set up some test cases and improve some simulation data. Thank you. I will welcome up my project